The last thing we're going to talk about today is how to use the function notation that we just discussed to solve the real world problems that we had done the other day. Okay, and so just to kind of give you some reminders of some things we've talked about, if you're given with these problems the factor, the growth or decay factor, then you use the normal equation. Like typically we would write it, it'd be y equals ab to the x power. And so we're going to be using that equation. Now, the reason why this one looks different is because a lot of times with real world problems, the x is going to be time. So notice instead of the x, I have a t that would represent time. And then, since we're going to be dealing with function notation, I rewrote the y as f of, this would be normally an x, but remember, we're using a t instead of the x, okay? So that's the only difference. So the same equation, we're just using the t and then the function notation. And so if you're given the factor, you use the regular exponential equation, standard form. If you're given the rate, that's where you had to do this 1 plus or minus the rate so that you could do the problem like this one, okay? And so just don't forget, if you're given the factor, use the regular equation. If you're given the rate, you have to just do that 1, and if it's a growth, you'd add it. Or if it's a decay, you would subtract it, okay? So let's just work through some problems, setting up equations and solving so you can get practice with that, all right? So with this one, it says a house costs $200,000. It will appreciate, which means it goes up in value, 3% each year. So if it's appreciating, that means it's a growth, okay? And notice 3% is a rate because it's growing at a certain percentage, which is a rate. So when you see a percentage growth, it's a rate, okay? So it says write a function that models the cost of the house over time, and then it wants you to express it in function notation. So because you're given the rate, you're going to use this equation right here. So if we're writing the equation, it's going to be f of t because it's dealing with time, and it says in the problem it's growing each year. So the t, we can go to the side, the t would be the years, however long it's been since you bought the house, okay? And then, if you remember, that front number is what we start with. So notice it says the house cost $200,000 to begin with, so that's our A. And then, just copying down the rest of my equation, it's a growth, so that's a 1 plus. So you take 1 plus whatever the rate is. So the rate was 3%. And remember from before, we have to change that to a decimal. So 3% to a decimal, you divide by 100, so that would end up being 0.03. And so that's your rate. That's what goes here, 0.03. And then it's to the t power. So there is your function, and then you can simplify it. So remember, we would usually add those numbers in the parentheses. So I'm just going to copy the rest of it down. And then if I take 1 plus 0.03, I get 1.03. And so that is your function, okay? Now it's saying find the value of f of 10. So if you watched the last video, remember you just take that and you plug it in for your t. So if we're finding f of 10, it would be f of 10 equals, you have 200,000 times 1.03 to the, well, t is 10. So what we are really finding is it's talking about the value of this house after so long, and then remember t is years. So what we're doing is finding the value of the house after 10 years, okay? So you could just type that in your calculator, and after you type it in, you'll end up getting 268,783. And I think that I had to round this to the nearest hundredth because the lowest that it goes is pennies, so that would be the pennies. And so this would actually end up being the value of the house after 10 years. So this is how much the house is worth after 10 years. So value of the house after 10 years. Okay. So that's kind of how they work. Look at what they give you, decide which formula to use, and then plug in, okay? So the next problem, it says, the most recent virus that is making people ill is a fast multiplying one. On the first day, so this is very relevant, on the first day of illness, only 2 virus bugs were present. Each day after, the amount of bugs triples, okay? So that means with each passing day, the number of people that have that virus will actually triple, which means tripling means that you're multiplying by 3. And so notice you're multiplying by a number. Anytime that you're multiplying by a number, that is a factor. Okay, remember a rate is a percent growth, so it's going to be a percent. If you're multiplying by a number, it's a factor. And so that means we're going to be using this equation. Okay, so we're going to come down here to write the function over time, and we have to write it in function notation, so we're going to use that f of t. Okay, we're going to use this equation. So how many did it start with? That would be my A. So it told me down here that the first day there were just 2 of them. So you would plug in a 2 right there. Okay, then it's tripling each time. So that means you're multiplying by 3. So that is actually what goes in here. You don't have to do anything fancy because whatever it is that you're multiplying by is what B is. And so it says, it tells you in the problem that it's tripling, which means you're multiplying by 3. So that number actually goes straight in there. And then you just put your t as your exponent. And so that is your function, okay? Then it says find the value of f of 5. So that means you take the 5 and you plug it in your equation. So f of 5 would equal 2 times 3 to the 5th power, okay? And when we type that in, we end up getting 486. So this means on the 5th day, because the time was 5 and t in this problem was each day, there would be 486 people that had that virus. So that's kind of interesting. So after 5 days, 486 people would have that bug or that virus. So this is important to know right now because this is actually how viruses are spread. They're spread exponentially, which is why it's kind of a serious thing when a lot of people start getting it. Okay, so let's do a couple more. Number 3 says Ethan's new Mercedes cost him $75,000. From the moment he drives off the lot, it will depreciate. So depreciate means it's actually going down in value. 20% each year for the first 5 years. Okay, so depreciate, if it's depreciating, going down in value, that's a decay. And notice they're giving us a percentage, so that means that's a rate. Okay, so when you're given the rate, you have to come up here and use the rate equation. Okay, and so when we write our equation, it says write the function that models the car's depreciation. And so we're going to write it down. It'd be f of t equals, what did it start with? That's my A, right? So it started off at a value of 75,000. And then it's a depreciation. So a depreciation, you're actually going to take 1 minus the rate. So that's when you use the minus in there. So it's going to be 1 minus, and then the rate that it's depreciating at is 20%, so you change that to a decimal, so you divide it by 100, so you'd end up getting 0.2, so it'd be 1 minus 0.2, okay, and then it's to the t power. So simplify the part inside the parentheses, so when I do that, just going to copy down my first part of my equation. 1 minus 0.2 ends up being 0.8. And then that's my equation. So it says find the value after or at f of 5. So if you think about what the t means in this problem, it's saying that this is happening each year. So my t would be however many years has passed since he bought the car. So when we plug this in, 75,000 You're going to plug it in for t in the equation. You're finding the value of this Mercedes after 5 years, okay? So you type that in, and I end up getting 24,576. So that means after 5 years, that is how much the car is worth. The car would be worth, if it was decaying 20% each year, value-wise, the car would be worth that much money. So it'd be worth 24,576. So that's a pretty dramatic drop compared to what it started out with. So that's something to keep in mind, because most cars, unless it's a classic, will decay in value, okay? So that's good to know. All right, so the last problem, it says you have a bad cough and have to attend your little sister's chorus concert or choir concert. You take cough drops that contain 100 milligrams of menthol in each drop. Every minute, the amount of menthol in your body is cut in half. Write a function that models the amount of menthol in your body over time, and then express in function notation. So if the amount of menthol in your body is cut in half, that means that you're technically multiplying by 1/2 each time. So you're multiplying by a number. That's when you use this equation, because that means that's a factor. So that's the equation we're going to be plugging into. So when we write the equation, the first thing is how much it starts with. So notice every time you take one, it's 100 milligrams to start with. So it's 100. And then what are we multiplying by? Well, we're multiplying by 1/2. And then you have your t. So that is your equation. It says it is safe to take a new cough drop after the level of menthol in your body is less than 5 milligrams. How long will it be before you can take another cough drop? So you're looking for the time here, okay? And so this is going to be one where we're going to just set it up so you can see how it's going to work, and then we will kind of talk about what's going on and how to figure it out. So what you're really doing is trying to figure out how long, so you're finding t, how long it would take to end up with 5 milligrams or less than 5 milligrams in your body, okay? And so you're looking for when that function would equal less than that number, okay? And so if you find out how long it would take to equal that number, you'll be good, okay? And so in a later class, you will find out how to solve something like this. But for this class, you're going to have to use trial and error. So you're going to take a guess as to how long and plug it in and then adjust accordingly. And so you could say, okay, well, what if we wait, I don't know, because this is every minute. So what if we wait 4 minutes? So in other words, if f is 4, or f of 4 is what we're finding, well, you would plug in the 4, okay, and you would see what that equals. So if I plugged that in, I would end up having 6.25 milligrams in my body. And so we're looking for how long it would take to have less than 5, right? So we're not there yet. So what if we wait another minute? So in other words, what if we wait 5 minutes? So then we would plug in 5 and see what we get there. So if I plug in and wait 5 minutes, we end up getting 3.125 milligrams, okay? Well, is that the first minute after it drops under 5? And yes, so your answer would be after 5 minutes, it would end up being less than 5 milligrams.